Assalamu alaikum. Dear students, in the previous lecture, we have discussed about the need for the measurement of high voltage, and after this, we have discussed about the peak voltage measurement with sphere gap, which is based on the principle that if an AC voltage is applied across two spherical electrodes and the voltage is uniformly increased till breakdown occurs, then the peak value of the arc wave is determined by V peak, which is equal to E multiplied by S, where E is the static breakdown strength of air and S is the minimum electrode separation at which the breakdown occurs. So from today, we will start towards the basic arrangement of sphere gap. We will discuss about figure A and figure B, which is the pictorial representation of sphere gap for voltage measurement. The figure A basically shows the horizontal arrangement and the figure B shows the vertical arrangement. From this figure basically show the two basic arrangements of sphere gap for measuring purpose. The horizontal arrangement is usually preferred for sphere diameter being less than 50 centimeter. Now in the figure, the sphere diameter is represented by D. So in horizontal arrangement, the value of D must be less than 50 centimeter. This arrangement is used for the measurement of lower voltage ranges. So the horizontal arrangement is used for lower voltage measurement. With large spheres, the vertical arrangement is chosen. It means that whenever we want to measure the high value of potential, high value of voltage, then we will require the greater value of D, or we can say that we require the greater value of sphere. It means that for higher voltages, the vertical arrangement is preferable. In both the arrangements, one of the electrode must be earth. In horizontal arrangement from the figure, it is clear that both the electrodes are earth, which is represented in this form. But in vertical arrangement, one of the electrode is earth and the other one is not earth. In both the arrangement, one of the sphere is static and other is movable so that spacing can be adjusted. So in horizontal arrangement, this sphere is movable as represented by these arrows, that we can adjust the length of the electrode, we can adjust the distance of the sphere by just moving from here. However, the other electrode is continuously fixed. However, the other electrode is completely fixed. In vertical arrangement, one of the electrode is fixed. However, the other electrode is movable. So by adjusting the space, we can measure the voltages. A minimum clearance around the sphere must be available within which no external object such as walls, ceiling, transformer tank, impulse generator, or supporting framework for the spheres are allowed. This portion is basically representing the clearing distance. In horizontal arrangement, this B arc in shape is representing the clearance distance. Now what will happen whenever there is a breakdown occur between the two spheres? The arc will be produced, and whenever the arc is produced, so there is a danger that the fire will occur. In order to extinguish the arc, one arm of the electrode should be moved from the previous position, from the initial position. So this movable arm will move instantly from this position to the other end. So it is better that all the spacing around the movable electrode should be clear. In horizontal arrangement, it should be like this one, and in vertical arrangement, it should be like this one. And we should not place any other thing within this clearance point. The minimum clearance is dependent on the gap spacing. Now this clearance point is basically dependent upon the value of the S, that how much is the space between the two spheres. That how much is the space between the two spheres. In case of horizontal arrangement, the height of the sparking point on the sphere above the horizontal plane must be within the given limits related to the sphere diameter. Here again the point is that the height of the sparking point should be above the ground point, because definitely at this level the testing engineer, the measuring engineer, or an electrical engineer is there. So it is better that there is an ample space between the sphere and the ground, so that the arc should not touches the base of the equipment. These conditions need to be in plane, must be within the given limits related to the sphere diameter. These conditions need to be met that the sphere gap is free from external electric field and surfaces which might otherwise distort the field between the sphere. So the other condition of this spacing is that the electric field which is going to be present here must not be distorted, its shape must not be distorted, its spacing over here and over here must not be distorted, so that from the external field and also from the surface. Otherwise we cannot get the accurate value of the electric field. The height of the sparking point P, the height of the sparking point P above the horizontal ground plane A, and the minimum clearance B around the sphere within which no external object are allowed are related to the diameter D and to gap spacing S respectively. So the researchers has provided us the standard values of A and B in relation to spacing S and D. And all these values are given in table 7.1. Here you can see the sphere diameter and the minimum and the maximum values of A and the minimum value of B. So whenever we are going to perform any measurement by using sphere gap, we keep a close eye on table 7.1, which is related to the clearance for sphere gap. Now, sphere may be made of brass, bronze, steel, copper, aluminium, or light alloys, and it is recommended that the surface of the sphere be cleaned immediately before use and be free from dust, grease, or any other coating. So here the authors has discussed about the construction of the sphere and what are the necessary precautions needed before the performance of the experiment. So the necessary precautions include that there must not be dust, grease, or any other coating on the surface of the sphere. The recognized standard diameter of the sphere in centimeters are 2 and all these values. The sphere diameters are to be chosen according to the peak value of the AC voltage to be measured. The spheres are carefully designed and fabricated so that their surface is smooth and the curvature is uniform. As the sphere is the backbone of the measurement of this experiment, so very much precautions and precautionary measures are needed with respect to the sphere. The radius of curvature measured with spherometer at various points over an area enclosed by a circle of point 3D above the spark point P should not differ by more than plus minus 2% of the nominal value. So here it gives the acceptable limitations in the measurement. Now we will move towards the measuring circuit. Continuous voltage measurement is obviously impossible with sphere gap, since the voltage source is short-circuited at the instant of measurement. A series resistance is usually connected between the source and sphere to limit the breakdown current. In the figure, the resistance is represented by subscript 2. So here the resistance is represented. So what is the purpose of the resistance? The purpose of the resistance is to provide protection between the source and the sphere in order to limit the breakdown current. For power frequency measurement, the protective resistance should have a value of 1 ohm per volts. The current needs to be limited to prevent oscillations in the measuring circuit and pitting on the surface of the sphere. The sphere gap circuit would also need to be automatically disconnected from the source once the breakdown of the gap has taken place. So all this is about the measuring circuit, that what are the precautionary measures we have to be followed while performing an experiment. Now we will move towards the correction of air density correction factor. As in the previous lecture I have discussed that the values of the sphere and the value of the E, and on the basis of the value of E and S we can measure the value of V peak. All the basic values are calculated and tabulated by the researcher on the basis of the standard temperature and standard pressure. But in Over daily life, the value of the temperature and pressure varies from area to area and season to season. The breakdown voltage of gap is proportional to the relative air density in the range of 0.9 to 1.1. The value of the peak AC voltage V naught obtained from the standard table is under standard atmospheric condition of 20 degrees Celsius and 760 mm of Hg. It means that all the values which are tabulated in table 1 or in table 2 or on the value are on the basis of the standard temperature and standard pressure. At ambient condition of T degrees Celsius and P mm of Hg, the peak value of Vmax will be related to V naught and is given by equation 7.1. So by using this equation, we can determine the value of the V maximum at any value of temperature and at any value of pressure. The air density values falling outside the range of 0.9 to 1.1, then the relation is given by Vmax, which is equal to K times V naught, where K is the function of air density factor and is tabulated in table 7.2. Now we have overcome one of the problem, that what will happen if there is a change in temperature and change in pressure is occurred. Now we will move towards the effect of humidity. The breakdown voltage in a sphere gap increases with humidity, and the effect is more for larger spheres. It has been found that within a humidity range of 4 to 17 gram per cubic meter, which amounts to a relative humidity of 25 to 95% for 20 degrees Celsius temperature, the relative increase in breakdown voltage is found to be between 0.2 to 0.35 per gram per cubic meter for a sphere of 100 centimeter diameter and the gap length up to 50 centimeter. For normal humidity range, no correction is needed. So definitely, as the temperature and pressure is going to change, we have to adjust the value of Vmax according to the requirement. Similarly, the effect of humidity is also there, and we have to consider this effect also. There is another effect, which is the effect of radiation. Because in the previous lecture and in today's lecture, our requirement is that there must be uniform electric field between the two spheres. So as the distance s increases, the field will not be uniform, and our requirement is that it should be uniform. Now what will be the effect of irradiation? Irradiation of the sphere gap increases the availability of initiating electrons in the gap, and therefore the statistical time delay is reduced. The important point to note is that if an initiating electron is not available, the gap may not break down if the peak voltage exceeds the DC breakdown voltage. For measurement of peak voltage of 50 kV or less, it becomes necessary therefore to irradiate the gap for obtaining consistent values. So it is necessary to irradiate the gap if we are going to measure the lower value of voltages. But if we are going to measure the high value of voltage, then there is no need. But the effect of irradiation simply means that we need an extra equipment to resolve the issue of the availability of the initiating electrons. Now we will move towards the accuracy, that what is the accuracy of this type of measuring instrument. Even under apparently ideal conditions, having made allowance for such factors such as air density, minimum clearance, smooth spherical electrode surface, and proper adjustment of spacing, a measuring uncertainty of 3% remain. It means that there is an error of approximately 3% is there in sphere gap for voltage measurement. So it is a huge value of the error. So definitely it is the limitation, it is the disadvantage of this sort of instrument. There are some calibration tables are given in which various distance gap and standard diameters are given based on the Indian standards and the British standard. Uh, but there are also some American standard and some other things are available. So as per the requirement of the WAPDA or NTDC, we will use such types of arrangements. So for today, we have discussed about the sphere gap for voltage measurement, wherein we have discussed about the construction and the basic working of the horizontal arrangement and the vertical arrangement. After this, we have discussed about the spheres, that of which material the spheres are made and what are the precautionary measures needed regarding the usage of spheres. After this, we have discussed about the measuring circuits and what are the protective devices we used in measuring circuit. And after this, we have discussed about the impact of temperature, pressure, humidity, irradiance upon the measurement of the high voltage using sphere gap. And in the last, we have seen that on the basis of the air density, minimum clearance, smooth spherical electrode surfaces, and proper adjustment, the accuracy of this measuring method is 97%. Or we can say that there is an error of 3% in the measurement. So for today, it's enough. And if you have any question, you can discuss with me during the discussion hour. So thank you very much and Allah Hafiz.